Good afternoon, everyone. So welcome to my YouTube channel, Maths Curriculum. So today we are going to see again an important question on functions of bounded variation. So let's see what is that question. So for any two non-negative integers n and k, you define function f and k on closed interval 0, 1 such that f and k takes value x to the power n sin pi upon 2x minus x to the power k if x is non-zero in closed interval 0, 1 and it takes value 0 if x is 0. In which of the following cases is the function f and k a function of bounded variation? So we have to tell in which case f and k is going to be function of bounded variation. Some condition on n or k it is given in options. Okay. So this question has been asked in CSIR NET 2020 exam. Okay. So what is first option? For all n greater than equal to 1 and for all k greater than equal to 0. Second option is for all n greater than equal to 1 and k is equal to 0. Third option is for all n greater than equal to 0 and for all k greater than equal to 2. D option is for all n greater than equal to 2 and for all k greater than equal to 0. So this in this question more than one answer can be true. So multiple option may be correct. So let's see what is the answer. So it is simple. Okay. How? Solution. So my f and k is what? This function. How it is defined? It is defined by this x to the power n psi pi upon 2x and minus x to the power k for x not equal to 0 and it is 0 for x is equal to 0. So f and k is defined on closed interval 0, 1. If you have a value x that is non-zero in this interval, you will take this function, and if it x is equal to 0, you will take x is equal to 0. Sorry, if you take f and k 0, if x is equal to 0. Now you put g x is equal to x to the power n sin pi upon x for x belongs to 0 for x belongs to 0, 1 close interval 0 for x 0. Okay. And you take fx is equal to x to the power k for x belongs to open interval 0, 1 close and 0 for x is equal to 0. Okay. Okay. So now we reminds you two results. Okay. Remember that you have a hk. Sorry, you have a function Lx is equal to x to the power alpha sin pi upon x to the power beta for x belongs to open 0, 1 close interval 0 for x is equal to 0. Then L is function of bounded variation if and only if alpha is greater than beta. So where you can find its proof? For its proof, see my lecture functions of bounded variation, practice that functions of bounded variation practice set stat 5. I have made a lecture practice set 5 on functions of bounded variation. You for the proof of this L is function of bounded variation, alpha greater than beta. You see my playlist on functions of bounded variation, and then you see functions of bounded variation practice set 5. Then you will see that this function is function of bounded variation when alpha is greater than beta. Now you see your function g. Now you see that when this function with gx will be functions of bounded variation. Here is 2 here, but 2 factor will not affect anything. So when g will be function of bounded variation, g is function of bounded variation if n is greater than beta. Beta is because x to the power 1 is there. You see that here in gx, what is beta? Beta is 1. And what is alpha? Alpha is n. So what is alpha? Alpha is n. Alpha is equal to n, and that is beta is 1. Okay. So this implies n should be greater than 1. When n is greater than means from where n will start? This implies n will be start from 2. Because n is greater than 1 means n will be start from 2. So n value is greater than 2. Okay. Now every monotone function is function of bounded variation. Bounded variation. For proof of it, you see, for this, see my lecture functions of bounded variation. Lecture 5, lecture 2 you see. You see playlist functions of bounded variation. You will find lecture 2 on functions of bounded variation. You can see that every function of every monotone function is function of bounded variation. You can find the proof of its proof there. Okay. So now gx, you observe that h is monotonically increasing function. So this implies h is function of bounded variation. Okay. So g and h both are functions of bounded variation. But you observe one or more thing, that note that here f is nothing but f and k is nothing but g minus h function, because f and k is difference of g minus k, and g and h are functions of bounded variation. Since g and h are functions of bounded variation, on 0, 1, we get the difference of two functions of bounded variation is function of bounded variation. Okay. So this implies g minus h is also function of bounded variation. But f and k is nothing but g minus h. So this implies f and k is function of bounded variation. When it will be, because f and k is nothing but difference of g and h, and when g is function of bounded variation, when g is function of bounded variation, if n is greater than equal to 2, and when, okay, and what is the condition where g is function of bounded variation? You take any k greater than 0. You take any k is non-negative, h is function of bounded variation because it is monotonically increasing function. So what is the condition? So this implies you join the condition of g for being a bounded variation, and you join the condition of h for being a function of bounded variation. So this implies f and k is function of bounded variation on closed interval 0, 1 for all n greater than 2 and for all k greater than 0. Because you take any k greater than equal to 0, h is going to be monotonically increasing function. So it is automatically function of bounded variation. So which option is correct? Let's see. So which option is correct? So option number D is correct. Okay. So today's question up to this. Thank you very much for today's question. Like, share, comment and subscribe my YouTube channel. Thank you very much for today's question.